So what if you could control your digital world without ever touching a screen or a keyboard? That's exactly the promise behind Meta's new neural interface wristband. This is a piece of tech that could completely change how we interact with computers. Let's get into it.
I mean, really think about it. Imagine sending a text message, skipping a song, or navigating a virtual world just by intending to move your finger. This is starting to sound a lot less like science fiction, right? A brand new conversation between humans and machines is starting, and it's happening right on your wrist.
For decades, we've been limited by our hands. I mean, the mouse and keyboard, perfect for a desk. And touchscreens, obviously, they changed the game for phones. But what about what's coming next? Like true augmented reality glasses. How are you supposed to click on something if your hands are full, or you're just walking down the street? Well, that is the exact problem this technology is trying to solve.
So how does this all work? Well, first we're going to break down what this wristband actually is. Then we'll get into how it reads your intentions. And no, it's not reading your mind. It's listening to your muscles. After that, we'll uncover the really cool AI breakthrough that makes it all possible, explore what it could be used for, and finally take a realistic look at the challenges still ahead.
Okay, so first things first. What exactly is this device? At its core, it's not magic or anything like that. It's actually just applied neuroscience.
To put it simply, this wristband basically listens to the electrical chatter that your brain sends to your hand. See, every single time you even think about moving a finger, your brain zaps these little electrical signals down your arm. This band is designed to pick up on those signals, right through your skin.
The fancy name for this technology is surface electromyography, or SEMG for short. It's just a way to measure the electrical activity of your muscles without needing any implants or surgery. You can think of it like an EKG, but for your muscles instead of your heart. And the fact that it's non-invasive, that's absolutely crucial for a device you'd actually want to wear every day.
So it turns out your forearm muscles are pretty much the control center for all those tiny, precise movements in your fingers. By placing electrodes right there on the wrist, the device can effectively eavesdrop on the commands zipping down from your brain. It turns your raw intention into a digital command. But you know, listening is one thing. Understanding what you're hearing is a whole other challenge.
So the band can hear the signals, but how does it make any sense of them? This is where things get really complicated, and honestly, where the true innovation is.
The thing is, the raw signals coming from your muscles aren't clean and simple at all. They're noisy, they're complex. It's kind of an electrical chaos. The AI's real job is to somehow find the one meaningful command that's buried inside all of that electrical static.
And this brings us to the huge problem that stumped engineers for years. Your unique body, your physiology, it means your muscle signals are totally different from mine. They're almost like a neural fingerprint. And because of that, a generic one-size-fits-all model just doesn't work. Not well, anyway.
You know, some early devices like the Myo armband tried to get around this with manual calibration. You'd literally have to spend minutes training the device every single time you put it on. It was a huge pain. So Meta's big goal was to create a system that could learn on the fly, one that works for anyone right out of the box. So how did they solve this neural fingerprint problem? Well, they didn't just build a better sensor, they built a smarter brain for it.
Okay, here's the secret sauce. The system starts with what's called a population model. It's been pre-trained on data from tons of different users, so it has a pretty good general understanding. But the real magic happens right in the middle, with a clever algorithm called a multi-armed bandit. It takes that general model and personalizes it just for you, in real time by learning from your actions.
Probably the best way to think about this multi-armed bandit algorithm is to imagine a smart coach in a video game. Instead of making you sit through some long, boring tutorial, it just watches you play. When you do something right, when the system correctly figures out your command, it sees that as a reward and uses it to refine its understanding of your personal neural fingerprint. It literally learns you just by watching you use it.
And the data shows that this really works. That purple line at the bottom, that's the baseline performance without this AI coach. But look at the green and orange lines. That's what happens when the learning is turned on. You can see a clear, steady climb in accuracy as the system gets more and more tuned in to that specific user. It actually gets smarter, just for you.
So this is a pretty fascinating technical achievement, for sure. But what does it actually mean for us? You know, in the real world, what is it all for?
The most immediate goal, the low-hanging fruit, is to create a seamless controller for AR glasses, like the Ray-Ban Meta smart glasses. But the potential applications go so much further. We're talking about way more intuitive control for advanced prosthetics, powerful new tools for motor rehabilitation after an injury. Heck, you could even create new forms of music or art. The possibilities are massive.
And you can really see the whole spectrum of possibilities here. On one end, you've got low-cost, quick-response devices for just everyday interaction. In the middle, you have tools for rehabilitation, and then all the way at the high end, you have these incredibly sophisticated medical diagnostics and prosthetics that cost thousands of dollars. This one single core technology could have an impact across every single one of these fields.
Okay, so the technology is incredibly promising. But let's be real, it's not quite ready for prime time just yet. There are still some pretty significant hurdles to get over before a device like this is just a normal part of our daily lives.
To really understand the road ahead, it helps to look back for a second. The Myo armband was a real pioneer in this space, but its reliance on that clunky manual calibration and its limited accuracy, well, it was eventually discontinued. Meta's big breakthrough is this AI-driven real-time personalization. This calibrationless approach is the absolute key that makes this new generation of devices even possible.
But some huge questions are still out there. How do we protect the privacy of something as personal as our neural data? Can the device stay accurate if you're sweating at the gym or if your hands are cold? Is it actually comfortable enough to wear all day long? And for the medical uses, navigating that complex world of regulatory approval is a massive challenge all by itself.
This kind of technology brings our digital and physical selves closer than they have ever been before, and it leaves us with a really fascinating question to think about. When your physical intentions can directly control your devices, where do you end? And where does the device begin? The answer to that question is going to define the next chapter of our relationship with technology.